All right, so now we're at 3.3 solving rational equations. So now we're gonna, instead of just looking at expressions, we're gonna throw an equal sign in there, and that will create equations. And so now we're actually going to be solving for answers. What would cause the equation to be balanced? Okay. So the definition of a rational equation is that an equation with one or more rational expressions is called a rational equation. Okay. So we have some examples here. Once again, rational is a fancy word for a fraction. Okay. So let's look at the steps for solving these. So step one is factor the denominators of all the rational expressions. Identify any values of the variable for which any expression is undefined. So remember, we have to find your excluded values. And so this is where it's going to be important, because what will happen is sometimes you'll solve it and your answer might be one of the excluded values, so you can't actually include it as your answer. And so we'll run into those a little bit more towards the end of the lesson. But that's why it's so important to check those undefined values and make sure you're aware of which ones they are, so that we don't make that mistake. Let's see. Step two, find the LCD of all the terms of the equation. Okay, we've done that before. That shouldn't be too bad. Now, this is what's going to make these actually easier. So whenever we were just kind of simplifying, adding, and subtracting them, it could get a little messy. What's nice here is once you find out the LCD, you're actually going to multiply both sides of the equation by the LCD. And what that's going to do is it's going to cause the fraction to go away. So we're not going to have any more fractions once we multiply both sides by the LCD. Step four, solve the resulting equation, and then just check it. Make sure it's not one of your excluded values that are undefined. So looking at this first one right here, I'm going to go ahead and put that 2 over 1. And so you look at 3, 2, and 1, so you got to find the LCD. So you're looking for a number that all three of those would divide into evenly, okay? And that's going to be 6, okay? So what we're going to do here is we're going to multiply both sides by 6. And basically what we're going to do is all the numerators are going to get multiplied by 6. So what's going to happen here is we'll end up with 6x over 3 equals 6x over 2 minus 12 over 1. So all I did was multiply all my numerators by 6. Now, what's nice about this is that now they're all going to reduce to where I won't have a fraction any longer. So 6x over 3 would reduce down to a 2x. 6x over 2 would reduce down to a 3x. And then 12 over 1, we'll just put that as a minus 12. And then from here, this should be a pretty simple problem for us to solve. There's a couple ways you could go about it. I'm going to go ahead and subtract 3x from both sides. By the way, there wasn't an excluded value because my denominator did not have a variable. So I didn't have to worry about that. In case you're wondering about step one, these first couple problems, we don't have to worry about that. All right, so let's see, subtract 3x from both sides, so we're going to have negative x equals a negative 12. That minus 12, we'll put that as negative 12. And then the last step we'll do is divide both sides by negative 1, so we get x equals positive 12. Okay, and if you want to, you can go ahead and plug it back in, and you'll see that the two sides will be balanced. Okay. Okay, so like I said, on these first couple examples, you don't really have to worry about step one. We'll look for it, but I don't believe we have a variable in the denominator spot on these first couple right here. So if you look at number 21, so you have a 5, a 3, and then basically a 1 underneath there. So there's no variables, so that means nothing is excluded. Nothing would cause you to divide by 0 and have undefined. So first things first, we'll look for our LCD. So I'm looking for a number that 5, 3, and 1 divide into evenly. Basically just focus on the 5 and the 3. That would be a 15, right? 5 divides into 15, so does 3. And the pattern you're probably noticing is it's usually the product of your denominators. Not always, but a lot of times. And so we'll see one that's a little bit more interesting on 23 in a minute. Okay, so just like the previous one, we'll start by multiplying both sides by 15. 15. Now, you can go ahead and do 15 times 3 if you really want to. I'm going to go ahead and leave it as 15 times 3x, and I'll deal with that in a minute because I want to simplify the 5 and the 15. I could multiply and get 45, and that's fine, but I kind of want to keep my number small if I can, okay? So same thing here, 15 times 2x, I'm just going to write that as 15 times 2x over 3, and then plus, well, 15 times 1, I'll go ahead and multiply that. I'll get 15 over 1 right there. So I decided to wait. The one up above, I went ahead and multiplied, but that's because the numbers were pretty small. Or I guess I didn't really have much of a choice because it was 6 times x, and then 2. But anyways, I'm actually going to wait till now because I'm going to go ahead and simplify it. So let's see, the 5 and the 15 reduce like that. So the 5 divided by 5 is 1. 15 divided by 5 is 3. So now I'm left with 3 times 3x, which would give me a 9x, okay, equals, and then this 3 divided by 3 is 1, and then divide 15 by 3, and that would give us a 5. 5 times 2x is 10x, and then I'm left with this plus 15 right here. And this problem is going to be pretty identical to the last one. The way you're going to solve this, we'll subtract 10x from both sides. And let's see, that'll leave us with a negative x equals 15. And I'm starting to run out of space, but what we'll do is we'll divide both sides by negative 1. And when I do that, I'll end up with x equals negative 15 right there. Okay. All right, let's take a look at 23. So once again, I'll go ahead and slide a 1 under that x, just personal preference. And so let's see. So, oops, I can move that a little bit out of the way. Okay, so my LCD here is going to be a little bit more interesting. Okay, and the reason why is because I got a 5, don't worry about the 1, a 10, and a 2. So they all have to divide in. I'm looking for the smallest number. So if I were to do 5 times 10, that's 50. It would actually work. It really would. But your numbers would be larger than they have to be. Or if I did 2 times 10, that's 20. And that would actually work also. But really, I don't really have to go above 10. 10 should be fine. All those numbers divide into 10 evenly. Okay, so see, I'm trying to pick a number that I'm going to multiply both sides by so that they all divide, that their denominators all divide evenly into that value so that their fraction will go away. So that's the idea right here. And if you overestimate it, you won't get it wrong. Your numbers will just be larger, and it could cause more opportunity to make a mistake, so we don't want to do that. So I'm going to go ahead and once again keep it separated. If you really want to, you can multiply it now if you want, but I like to keep them separated, and I think that'll help us out later on as they get a little bit more complicated. So if I were you, I'd kind of follow this. So let's see, 5 times 10, doesn't matter what order I put that in, and then over 2. And then now I'm going to reduce the denominators with the 10 that was introduced on each one. So right here, that 5 will go to a 1, the 10 will go to a 2. So this whole thing right here simplifies to a 6x. Then 10x over 1, we'll just write that as minus 10x. And then let's see, the 10's reduced just to 1s. So you're just left with an x there. And then let's see, the 2 and the 10 will reduce. So that will leave me with a minus 25 right there. Okay, so then next we'll clean this up a little bit. So 6x take away 10x would be negative 4x. And then equals x minus 25. And then what we'll do is we'll go ahead and subtract an x from both sides here. And I'm going to have to give myself a little more room. And so let's see. That will cancel out. So I'm left with negative 5x equals negative 25. And then we'll divide both sides by negative 5. Those cancel out. I'm left with x equals positive 5. And there we go. And once again, I don't have any restricted values, so I don't really have to worry about that. But we will in a moment. Okay, looking at 25, so this is interesting. So let's see, looking at my denominators, I gotta find my LCD, no excluded values. So whatever I'm looking for has to divide into 6, 8, and 4 evenly. And a lot of y'all might be able to figure that out in your head, and that's good. But I'm going to go ahead and show you kind of the more detailed way of doing this in case you're having any problems with this. So what you're supposed to do is break the numbers up into primes. So 6 is the same thing as 2 times 3, right? And then 8 is the same thing as 2 times 2 times 2, which is the same thing as 2 to the power of 3, right? And then 4 is the same thing as 2 times 2, or that's the same thing as 2 to the power of 2. So the way you find the LCD is you go through and you look at each prime number and you take the one with the highest power. So looking through here, I've got 2 to the power of 1, 2 to the power of 3, and 2 to the power of 2. So I take that one. That's going to be part of my LCD. There's more to it, though. Then you look at other prime numbers. The only other prime number is 3. And so that one comes with it. So whatever this is, that's what your LCD is. Well, 2 to the power of 3 is 8. So this would become 8 times 3, which is 24. So that's what the LCD is, okay? Like I said, a lot of y'all could have probably figured that out without doing this, but this is kind of the more proper way of finding your LCD is you take that and you list the numbers out as multiplication of prime numbers, and then you take each prime number that appears and you take the one with the highest power. And that's how you do that. I don't think you'll have to resort to that very often. The numbers are going to be fairly small, but I thought that was probably worth showing that to you. Okay, so now that I know the LCD, that's what we're going to multiply both sides by. So we're going to multiply by 24 on both sides. Now, once again, I'm not actually going to multiply it yet. So what I'm going to do here is this is going to be 24 times x plus 3, which should get distributed to both, but I'm not going to distribute yet. And then equals, I'm going to have 24 times 3 all over 8, and then plus 24 times x minus 5, and then that's all over 4. Okay, so all I've done so far is I multiplied all my numerators by the LCD, which was 24. Okay, so then what I'm going to do next is I will go ahead and reduce the denominators with those 24s. So the 6 reduces with 24 down to a 4. The 8 with the 24 down to a 3. And the 4 with 24 down to a 6. Okay, now just to kind of keep everything clear, I'll go ahead and rewrite it before I distribute. If you're comfortable with distributing now, you know, I'm fine with that, but I'm going to go ahead and rewrite this. So 4 times x plus 3 equals 3 times 3, then plus 6 times x minus 5. And this is nothing new. You should know how to do this. This goes back to our very first unit, so this should be pretty basic. So we'll start by distributing the 4. 4x plus 12 equals 3 times 3 is 9. Then we'll distribute the 6 here, so that'll be plus 6x minus 30. Okay. And then let's see, let's clean this up a little bit. I've got a positive 9 and a minus 30, so they're on different teams. And at this point, you know, you can use a calculator. Hopefully you're not having to grab for it too quickly. Hopefully a lot of this you can do on your own. But at this point, I can't keep going over that. So let's see, that's going to be negative 21 and then plus 6x. And then now what we're going to do is you got to isolate the x to one side. And so I typically like to remove the smaller amount. So I'm going to subtract 4x from both sides. And so that'll leave me with 12 equals negative 21 plus 2x. Okay. And then what we'll do here is it looks like I need to add 21 to both sides. And I'm going to bring this up here. And so let's see, that'll leave us with 33 equals 2x. And then we'll go ahead and divide by 2, divide by 2. And you can just leave it like that. You can leave it as 33 over 2. Or if you really want to, you could write it as, what is that, 16.5. You know, typically I just leave it as a fraction. But if it comes out to like a nice decimal, where it's not like a really long decimal repeating or anything like that, then that's fine. but for the most part, I'm probably just going to keep it like that. And you don't need to turn it into a mixed number. You just keep it as an improper fraction is fine. All right, let's see. So I'm going to do one more here, and then I'll probably start the part 2 video down below. And that's where we'll start to have to worry about restricted values down here. Okay, so this one, though, we don't have any in the denominator spot, any variables, so we'll just look at our denominators to figure out our LCD. So in this case, let's see, we have a 3, 1 doesn't really play a role, 7. So that's going to be a 21. So we're going to multiply both sides by 21. Let's see, 21. Okay, so once again, I'm not actually going to distribute it yet. I'm going to leave it right there over 3 equals, and then let's see, 5 times 21. If I wanted to multiply that together, that's not a big deal. I'll do it in a minute. Then let's see, minus 21 times x plus 2 all over 7. Now let's go ahead and reduce this. So let's see, the 3 and the 21. We'll multiply that together in a minute. Let's see, the 7 and the 21 down to a 3. Now, once again, if you feel comfortable distributing now, that's okay. I'm going to rewrite it first. Just be careful because that 3, you're going to distribute the minus with it. So if you do want to distribute now, just be aware that the minus needs to go with the 3. So let's see, I'm going to have 7 times x plus 1 equals 5 times 21, which is 105, minus 3 times x plus 2. So now we'll distribute the 7 and then distribute the minus 3 also. So let's see, I'm going to end up with 7x plus 7 equals 105 minus 3x minus 6, okay? And then we'll clean this up, the 105 and the minus 6, and I'll continue up here. So let's see, we still have 7x plus 7. And on the other side, let's see, that'll leave us with 99 minus 3x. Okay, so now I need to pick a side for the x. And what I'm going to do here is I'm going to add 3x to both sides this time. And so let's see, that'll leave us with 10x plus 7 equals 99. Okay. Then what we'll do here is I'll go ahead and subtract 7 from both sides. So I end up with 10x equals, what is that? Let's see, 92, I believe, right? Okay, then we're going to divide both sides by 10. Now, you do want to reduce this. If you don't reduce it, you're going to lose points, okay? So 92 and 10 are both even numbers, so they're definitely at least divisible by a factor of 2. So that's where I'll start. I'll divide each one of those by 2. And let's see, that should leave me with, let's see, what's that, 46 over 5. And then 5 and 45, I can't reduce that any further, so that's what I'm looking at right there, okay? And, I mean, if you wrote that as a decimal, that'd be okay. I don't really prefer it, but you could, it'd be 9.2. But it's just to be safe, I like to stick with fractions because those are more accurate, especially when you start getting decimals that aren't so clean, okay? So I'll go ahead and stop here for part 1. Part 2, that's where we're going to start seeing restricted values play a role. So we didn't see that here because none of the denominators had a variable, but you'll see in the next video that we'll have some variables down there, so we have to take that into account when we get our answers.